Hello, I would like to introduce to you Gertboard Revision-2. So this is the board which will go into final production. The board is just like the previous board, connected through a flat cable to the Raspberry Pi over here, but a number of changes have been made to the board. There was a lot of analog components over here, resistors and transistors, which have all been placed in one IC, so that saves you a lot of soldering. And the PIC has been replaced by an Atmel chip, which is more compatible to the Arduino flow control. I've added a couple of push buttons which give you input, and there originally was an SPI interface here, I/O expander. The SPI interface to that has been replaced, and now we have two new chips here. One is an analog to digital and one is a digital to analog converter. Both are 2 channels. So I'm going to show you the capabilities of this board. I start off again with the LEDs. You can run the LEDs. I'm only running 5 LEDs now because I need a lot more signals for the other interfaces. And I've added some nice patterns there. So this shows you the output capability of the board. The next thing I'm going to show you are the push buttons. The push buttons, I've connected 2 push buttons, and default the input is high using the pull-up resistor of the Raspberry Pi. So if you press your push button, you pull the signal low, which is shown here by the button going low on the screen. And of course there's a button at the other side as well, which you can push. So you see you get direct input from your buttons into your Raspberry Pi. And of course you can press both buttons low and release them in any order you want. Next, what I'm going to show you is the analog to digital converter. I cannot show you the digital to analog converter yet. For that you have to look at a picture on the website. On the Gertboard forum there's a beautiful picture which shows you the digital to analog converter on a scope screen with some beautiful triangle waves on there. So now we're going to do the analog input. So what we have here is a horizontal bar which shows you the analog voltage coming in over this voltage regular resistor. So if we increase the voltage, the bar goes to one direction, and if we decrease it, it goes to the other direction. And there's no cheating here. It really shows you a linear relation between the external analog voltage and the signal read by the Raspberry Pi. So at the moment you see a very low voltage, 0, and increasingly going to maximum, which at the moment is 1023. Now I'm going to show you the motor. You've seen the motor before in the previous video, but this time I've connected up the Raspberry Pi pulse width modulation output. Means that I can control the speed of the motor. What you see happening here. I have only one pulse width modulation output, but by playing with the voltage on the other pin on the GPIO, I can use it not only to change the speed, but also the direction. So we still have speed control in both directions. Now I can't show the Arduino in action, the Atmel chip, but I managed to transmit RS-232 UART characters, asynchronous US character, from the Raspberry Pi to the Arduino and back again. And the last thing I'm going to show you is how you can combine some of these functions on the board. So what I'm taking the analog control and using it to control the speed of the motor. And reverse again because the middle position is stopped. So the board will go in production next week. So I hope to have about 1,000 boards back in about 4 or 5 weeks time. And the plan is that they will be sold through the normal raspberrypi.com sales site. Thank you.